Hi, welcome back to my channel. This is Kidomuju from KD Concept Researchers. Please kindly like and subscribe to our channel so that you can always get our videos while it drops. Okay. We are also going to be looking further into data analysis in SPSS. Now, if you remember what we did in Excel, there was a time we looked at ANOVA and t-tests. Now, here in SPSS, it is best to handle such analysis, such statistical analysis using parametric, non-parametric tests. Now, non-parametric tests here, these are also statistical tests, which are equivalent to the parametric ones. And in statistics, we have parametric tests and non-parametric. Now, for parametric tests, you have things like your ANOVA, your chi-square, your t-tests. While the non-parametric now will have statistics like the Kruskal-Wallis test, the Friedman test, and of course the Wilcoxon test, just to mention but few. Now, the basic difference between the parametric and non-parametric is the non-parametric is applicable when some basic criteria about the data is not known. For instance, for you to conduct ANOVA tests, there are some criteria that must be met. For example, the data must be normally distributed, so normality must be in place, and also heteroscedasticity to show that the data is all set for your test. Now, whereby some of these parameters and some of these criteria are not known, it is best you handle your data as using non-parametric tests. And that is what we're going to be modeling today. Let me share the Microsoft window. There we are going to be entering our results. Hold on. Okay. So on this screen right here, this is where we are going to be entering our result. Now, look at the caption of the table. Say comparison of GATT parameter within the group using Friedman test. Now, we're going to be modeling two tests. The first we're going to be looking at tonight in this class now is the Friedman test. Now, Friedman test is simply a non-parametric test that is used to compare difference in mean of 3 or more samples from the same group. Let me repeat that again. That the Friedman test is a non-parametric test that is used to compare difference in mean between 3 or more variables from the same group. Now, similarly to Kruskal-Wallis, Kruskal-Wallis is also a non-parametric test for comparison of difference between 3 or more variables, but this time around between groups. So there's comparison within groups and there's comparison between groups. When you're comparing 3 or more groups, you use Kruskal-Wallis. While when you're looking at different variables within a particular group, you use your Friedman test. So this table here is where we're going to be tabulating our results. You can see the mean, plus or minus standard deviation for baseline, mean intervention, and post-intervention. So we are going to be comparing performances of these particular items here. We have the step length, stride length, natural gads, maximum gad speed, and cadence. This is a medical related data, so I want to use it to model the class tonight. But all you need to pay attention to is that we have 3 different groups, subgroups in the same group. One, we have a baseline, we have midpoint, we have post intervention. Now, also, the group name is treadmill. We also have another group here called progressive resistance, and then the third group called conventional. So the comparison is going to be between groups. I'm going to use just the first group to model this. So we are going to model it using this group called treadmill. So that's what you're going to be using to model for tonight, to compare difference in performance of step lengths between baseline, midpoints, and post-intervention. As you can see here, we'll get the Friedman test statistic value and also the p-value. And over here, we do a post-hoc test. That's why we call it pairwise comparison. This is for post-hoc. You can call it post-hoc test, where we now compare between two samples. That is pairwise comparison of all samples that are involved. In this case, now we have sample A, sample B, and sample C. So the pairwise is going to be between these three samples. Now let's look at the data which we're going to be using, and then let's see how we can transfer this data into SPSS. Okay, now the second file I sent, this is the data which we're going to be using to model the course. Now on this data here, if you pay close attention, you see group 1 baseline. So baseline is the group 1, but the group 1 is also subdivided into 3 subgroups. We have the baseline, we have the mid intervention. Then if you also scroll down, you have the post intervention. Then we are done with group 1. Now we have here group 2. This one here is group 2. Now group 2 also has the same baseline, mid intervention, and post intervention. Now we have our group 3 also having baseline, mid intervention, and post intervention. So we are going to be comparing between the performances of each of these variables, step lengths. So step lengths in baseline will be compared to step lengths in mid intervention, and also step lengths in post intervention. Now, how do we do that? We need to move our data into SPSS. So I'm going to go over to SPSS now. We are going to create a variable called step lengths. Okay, so I'll come to my variable name. The first one, I'll type step length. So I'll call it step length 1. That would be for baseline. Then I'll also create step length underscore 2 for the second data, that is midpoints. Then I'll call this one step length underscore 3. This is now for post, the post, yes, post intervention. Now I've created these 3 variables: step length 1, step length 2, step length 3. It is now for me to go back to my Excel. Now this is the step length for the very first one. I'm going to highlight it, copy it with Ctrl+C. I can even share my screen so that I can just copy them right ahead. Then I'm going to paste it exactly under step length 1 with Ctrl+V. Remember that this data can be created directly into SPSS without doing it in Excel. But the data was supplied to me from Excel, so I'm now moving it to SPSS. So, no. I should paste it from number 1. Good, there are 16 in numbers. You can see the count here is 16. Now, that's the step length for baseline. I will now come down again. For mid intervention, I will bring in the same data again. Let me go back to Excel so you see what I'm doing. Okay, now this is step length for the second group. I will still copy it again. Then switch back to SPSS. By now, I believe we are very familiar with how I'm switching these windows. Now in SPSS, I will paste this under step line 2. See, they have equal lengths. Now I will go back to my Excel, scroll down again, and then copy step lengths. Let me show that. I'll still come down again and copy step lengths group 1, but for post intervention, I will copy the same value. Copy. Then back to SPSS now. Now I'll paste that here. Right click, paste. Now what I have done is I have transferred the step length value for group 1 for base, midpoints, and post intervention. You see that they are all equal here, 16 of them. Now we want to compare the performance of step lengths under group 1 between baseline, pre-intervention, mid-intervention, and post-intervention to find out if there is any significant difference between these 3 data sets, which we are collected at different stages in group 1. So the first thing we've done now is we have moved our data into SPSS. Now, the next thing we need to do now, luckily it's a very small size data. So if it was a very long data, you may need to check for missing values. Check if all data has been well entered. Then to conduct the non-parametric test now to check for significant difference between these 3 groups here by comparing their mean, we have to go to analyze. Now pay attention, this is now how to conduct the Friedman test. Remember that the Friedman test is a test for difference in mean when you're comparing 3 or more variables from the same group. All right, so from analysis, we'll go to non-parametric. Every test will be conducted in this class now is going to be from this place, non-parametric. Then if you scroll down here, you see legacy dialog. Now from legacy dialog, we are going to select K-related sample because we are looking at 3 related samples, same step lengths, but in 3 different subgroups. So we select K-related sample. Now, this dialog box here is very important. This is now where you have to input the variables which you want to use for your Friedman test. Remember that there could be some spreadsheets where the number of columns are so many. But if you want to concentrate on just some of them, you can just move those ones into the test variable. But for this test, we are using all variables. So I'm going to highlight them all and move to test variable. Now let's go to statistics and see, okay, they said, do you want to add descriptive statistics? I say yes, so that I can be able to get the mean and standard deviation. Okay. Now they're asking what kind of non-parametric test do you want to use to check for this? Now you see I've ticked Friedman test. By default, it should be ticked, but if it is not ticked, you can also tick it. These are other non-parametric tests, Kenwall and then Cochrane, but we're using Friedman test. Now make sure it's ticked and then you okay. We shall now switch over to the results window. Okay. Now over here on our result window, this is now what we have done. You can see the descriptive statistics for the 3 variables tested for step length 1, step length 2, and step length 3. We see the mean, we see the standard deviation, the minimum and the maximum. However, what we need is just the mean and the standard deviation. Now, coming down, you see the Friedman test showing you the rank, how it was ranked. That step length 1 was ranked as number 1, followed by number 2 and number 3. Now, the most important output is this one here called the test statistics. Now, the Friedman test uses a chi-square test. It's equivalent to a chi-square test. Now, the test statistic is 32.0, and then the significance is 0.000, which shows that the test is highly significant. Now, the test is significant simply means that there is differences in the mean of the three interacting variable, or at least one of the mean differ from others. That means we now have to conduct a post-hoc test to find out which particular pairs are similar or dissimilar. But firstly, we need to move some of these results to our Microsoft Word documents. So pay attention. I'm going to split the screen and then switch to my documents, which I have created. So I'm trying to find the table. Okay, so now this is our results window where we're going to put in results. Now I'm going to share the screen. Now, you see here we have the first thing they're asking us here now is mean plus or minus standard deviation for baseline, midpoint, and post-intervention. Now remember that baseline is step length 1, midpoint is step length 2, and then post-intervention is step length 3. So the mean for step length 1 is 32 points. Let me just say 19. Then let me copy this plus or minus. Copy and paste. Okay, then plus or minus, the standard deviation is 9.89. So 32 plus or minus 9.89. That is for baseline. Then for midpoint, which is second one, we have 47.75. Again, plus minus 7.80. Then also going to towards the right, for step length 3, we have the mean to be 54.119. Then plus or minus 9.01. Okay, now the Friedman value is this value here, the chi-square value there, which is 32.00. I'm taking it to today's more places. Then our p-value is 0.000, which is highly significant. Now, the last part of this has not been done, which is the pairwise comparison. So I'm going to minimize the Microsoft window. Let's go back to the SPSS to now conduct the post-hoc test. Now, post-hoc test is simply done when there is significant difference in a test, be it Kruskal-Wallis or Friendman test. Where there is significant difference, you now want to check where that significance lies. That's now where I do a post-hoc test. Now, how do we do that post-hoc test? Pay attention. Remember, all forms of analysis, you have to go from the analysis window. Then from analysis, again, we'll go down to non-parametric. Then we'll go over to legacy dialog. Now, remember, for the Friedman test, we use k-related samples. Now, this time we are going to be using 2 related samples to do the post-hoc test. So I'll select 2 related samples. Now, this window is now where you pair your variables. So for the first pair, I'll click on this variable, move my step length, click on step length and move it. So I'm going to compare between step length 1 and step length 2 as my first pair. Now I will click on number 2. Number 2, I'm going to be comparing step length 1 and then step length 3. And then finally, we now compare between step length 2. Once you click on it, you move it, and then step length 3. So you see, we have 3 groups here now. We have A and B, A and C, and B and C. Of course, when you're comparing 3 things, those are the 3 possible cases. You compare between A and B, A and C, and then B and C. Good. Now they're asking of what post-hoc test are we doing? You say Wilcoxon test. It's marked by default. If it's not, you tick the Wilcoxon test. Make sure you enter your pairs very well, and it should be in order. Just in case your variables are more than 3, make sure that there is always this pairwise comparison. Every item must be compared to another item. So if you have 4 items, that is how the number of pairs will also increase to 4. Okay, so all is set for our Wilcoxon test. I'll click on OK. Now switching over to output window. Now in our output window, you see the Wilcoxon test, and it's trying to give you some basic statistics. But scroll down. Our interest is in this test statistic. Now, if you look at the test statistics, it uses the normal distribution, just like our t-test. So this is equivalent to t-test. Now, the first pair here is step length 2 and step length 1. So this one is comparing between 1 and 2. The second one is comparing between 1 and 3. And the third one is comparing between 2 and 3. If you look at their p-value, you find out that they are all significant. So it means that there's significant difference between step length 1 and step length 2. There's also significant difference between step length 1 and step length 3. And then there's significant difference also between step length 2 and step length 3. Because they are all significant. You see their p-value is approximately 0 here. The significance for 2 to here is 0. Now, how do we now report our post-hoc results in our Microsoft Word results file? Now, let's go over there. Now, because they are all significant in our pairwise, we are going to be saying A and B are significant. Small a. Remember that the A is, our baseline is A, mid is B, post is C. So A and B are significant, comma. Also, A and C showed significant difference, and also B and C. Some person must have seen this in research papers and maybe wondering what they are. So these are pairwise comparison between the 3 data points tested. Now, we have them all 3 here because there is significant difference in all cases. There are sometimes you test and you find out that probably just 2 is significant. Remember that the test to be significant if at least 2 pairs show significant difference. But in our case, all three pairs here show significant difference. So this is how to tabulate our results. Thank you for watching this video. You can also check out some other videos that are prerequisite to this one on our course series in data analysis using Microsoft Excel. Please kindly leave your questions in the comment section and we'll attend to them. Also remember to like, share, comment, and most especially, please kindly subscribe to this channel so that we can always serve you better. Thank you.